So good morning, everyone. Welcome to new timing, new session. Well, every day the time keeps on changing, but that's how change is the only constant in life. Yes, beta. What happened? Everything okay? Change is the only constant in life, and that is the only thing that is constant is change. So let us now begin. And as you can see, the heading of this class is COM, Center of Mass. Again, what do you mean by center of mass? Anyone? Any idea? What do you understand by center of mass?
Sir, it is an imaginary. Hello, sir.
Yes.
Am I audible?
Yes, you're audible.
Sir, it is a imaginary point where the whole mass of the body is supposed to concentrate it.
Why? Why we want the entire mass of the body supposed to be concentrated at one point? What happiness does it give us? So first of all, you must understand that center of mass is an imaginary point. There is no point. There does not exist a point physically. It may lie inside or outside of body. For a body, it may lie inside or it may lie outside a body. Now, what is the actual characteristics of center of mass? The motion of the entire body can be understood by the motion of center of mass. In translation, what does that mean? This is the body. Now, this body is moving like this. This is pure translation. Now, if you want to understand the motion of this body as one, his body is moving in translation, we don't have to actually draw this body. Now, up till now, what we had done, a car is moving with a velocity v. We did not draw a car, we just draw a point. Yes or no? Because that point represents the motion of the entire car. That point, which represents the entire motion of a body in translation, is known as your center of mass. Do we understand this?
Yes, sir.
Now, if a force is acting on a body, now if a force acts on a body, what that force can do? If a force acts on a body, what that force can do? Tell me first. Suppose if a force acts on a body, let us say this is a body that I have. This is the body that I have. And let us say a force acts here on this point. What will this force do? This is a rod, let us say, since you have already done rotation before. This is a force applied on a rod. This rod, let us say, is kept on this. This is a table, and I've kept a rod on this table. I hope you can see this rod. Oops. I've kept this rod on a table, and then I apply a force like this here. What happened to the rod? What type of motion this rod has? What happens to this rod? I apply a force like this. A rod is kept on a table and I apply a force like this. What will happen?
Rotate, sir.
Only rotate?
It
Only
also
rotate.
it also moves, sir.
It also moves. So it will have two types of motion. One is translational motion and one is rotational motion. So we'll have to understand both of these motion to understand the entire motion of this rod. I should not throw this because it is dangerous. This pen, I throw it up, tongue, 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 tongue. It goes like this. Wee, 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 wee. It is having both type of motion. What both type of motion? It is also having translational motion and it is also having rotational motion. One body, one point of this body is still moving straight up and straight down. Even if I throw it like this, oops, even if I throw it like this, one point of this body is still just moving up and coming down. It is only moving in translation. What is that point?
Center of mass.
That point is the center of mass. So if we only understand the motion of that center of mass, we can understand the translational motion of this body. Do you understand this?
Yes,
So
sir.
how will we understand the motion of that center of mass? We can assume that the entire mass of the body is at this point, and this force is not acting on this point. This force is just acting on this point. This assumption will give us the motion of the center of the mass, or it will give us the translational motion of the entire body. It will not tell us about the rotational motion of the body, but it will tell us about the translational motion of a body. So center of mass is an imaginary point where you can imagine what? Entire mass
Of the body
is concentrated. Entire mass is concentrated. Force is applied on this point. The force may be applied anywhere, but you can assume that the force is applied at this point. And the motion of center of mass gives us the translational motion of the body. Do we understand this, or this has gone above it saying bye, 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 bye? I'm going. Gone? Huh?
Sir?
Do we understand this?
Yes, sir.
So this is just a point to simplify our imagination of motion of a body which has got a shape. To understand the translation motion, assume that the point, at one point the mass is there. Assume that at that point all the forces are acting. Study the motion of this point and you will get the translational motion of the center of mass. That is the only significance of the center of mass. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'll give you a minute to note this down. Once you are done, please let me know.
It's done, sir.
It's done, sir. Well done, sir. Then, if you have many particles in a body, or if you have a system of point masses, you can see these point masses, point mass number 1, point mass number 2, point mass number 3. Do you see? Point mass number 1 has mass m1, point mass 2 has mass m2, point mass 3 has mass m3, and so on. And they have their own position vectors, r1 vector, r2 vector, r3 vector. Then the position the position vector of center of mass can be written as m1 r1 vector plus m2 r2 vector and so on up till mn rn vector divided by m1 plus m2 up till mn. I hope all of you know this. Yes or no? No, yes. So I can also write it like this. It is summation of mi ri I equal to 1 to n divided by summation of mi from I equal to 1 to n. The summation of mi is the total mass, so I can write it as capital M. Summation of mi ri. Don't get confused with the complicated nature. It is just the way of writing it in math. Do we understand this? 1 minute you have to try and note it down.
Done, sir.
Okay, then if you know the position vector, you can also write the sometimes we may not use position vector. We may only find the x coordinate or the y coordinate or the z coordinate of the center of mass of the particle or the system of particles. So xcm will become summation of mi xi divided by m. Do we understand the meaning of this?
Yes, sir.
Similarly, you can write the value of ycm and zcm. Yes or no? Write it. You have 2 minutes to do this. This is the formula that is what we are going to use in majority of the cases. I hope you understand this. Yes or no? No, yes.
Yes, sir.
We might not use the vector form. We might use only the x, y, and z coordinate.
Done, sir.
Everyone has noted this down, beta? I see students writing, so let us give everyone time. When everyone is done, please raise your hand so that I know that we are done. Then only we will move forward. Once everyone has done this, that is the time that we move forward. So I think now everyone has done. So let us move forward. Now, what do we do moving forward? Since we have seen the formula for center of mass, we can just do this question and remember the result of this question. And because this question will come many times, this formula will come many times. So you have two blocks, two bodies of mass m1 and m2. The distance between the two bodies, as you can see, is r. You have to find the position of the center of mass. Once you find the position of center of mass, remember this always. We'll use this many times. Remember this. Give you 2 minutes to find out the center of mass. Find out the value of r1. Basically, they're asking you. Sometimes you might use the value of r1. Sometimes you might use the value of r2. R1 and r2 will come in terms of m1, m2, and r. 2 minutes. And remember the result. Yes, bacha, anyone with an answer?
Yes, sir. M2 R by M1 plus M2, sir.
What value are you telling me? Are you telling me the value of R1 or are you telling me the value of R2?
Sir, R1 is equals to M2 into R by M1 plus M2. R2 is M1 into R by M1 plus M2, sir.
Okay, so remember these important points that you are saying and remember them always. Note them in important points. R1 by R2, the ratio of R1 by R2 will be M2 by M1. Do we understand this? Yes or no?
Yes, sir.
Center of mass would be closer to the particle which has got more mass. Center of mass will be away from the particle which has got less mass. Do we understand this?
Yes, sir.
And R1 will be equal to M2 upon M1 plus M2 times R. R2 will be equal to M1 upon M1 plus M2 times R. Remember this. This question may not be this question. A similar question has come many times in exam in JEE, and we shall start with the same. Read the question, get the answer, and stay happy. So this is the question. Question number 1. Do it. Get me the answer.
Sir, it's done, sir.
It's done, sir. Then tell me the answer, sir.
Sir, it is 2 meters from 1 kg, sir.
It is 2 meters from 1 kg. And that is correct. Everyone got the answer? 1 kg block is put at x is equal to 0. 1 kg is x equal to 0. 2 kg is x is equal to 3. We just put the answer. We just put the answer. We just put the value, get the answer, and stay happy. We only have to find the x position. Y is not there. So x position of the center of mass is m1 x1 plus m2 x2. You can put it this way also, divided by x1 plus x2. X1 plus x2 divided by m1 plus m2. You put the values, get the answer, and stay happy. Everyone got this? Yes or no? Can I have reason from everyone?
Yes, sir.
Well done. Let us move quickly now because the time is a luxury that we don't have. Here's the next one. Do it fast.
Sir, we can't see next one.
You will see. When time comes, you will see. It's a कहावत in Hindi. समय से पहले और वक्त से ज्यादा कभी किसी को नहीं मिलता. In short, it means before time and more than your destiny, you never get anything. So your time has come now. So you got this. Let's see what's in your destiny. Do we have anything that looks like an answer? Feels like one. Yes, sir. No, sir. Better I go, sir.
Yes, sir. We are getting.
Okay, okay, okay. Get. Do it fast. Time is a luxury that we don't have, my dear friends. Giving you time. I want you, all of you, to do this. 1 more minute. Don't worry. Our course has shaped up fine. You're going at a good pace. That's what I feel.
Sir, it's 3i plus j minus k by 2, sir.
Just wait. I need to check the answer. Yes, the answer is
3i plus j minus k by 2, sir.
that is correct. 3i plus j minus k by 2. That is the answer that you had to get. So how did you get it? The position vector of the center of mass is simply summation of mi ri divided by total mass m. Total mass is 1 plus 2 plus 3, 6. Multiply 1 with r1, multiply 2 with r2, and multiply 3 with r3 divided by 6, and you will end up with the answer. Yes or no? No, yes. I am not going to waste any more time in showing you this. I hope everyone understands this. Move on to the next one. The more the number of questions that we do, the more is the probability that similar question will come in the exam. The more is the probability that you will do it, and your time for seeing the question comes now, and I wait for your answers. 4 particles of mass 1, 2, 3, and 4 are placed on the vertices A, B, C, D of a square of side 1 meter. Find the position of the center of mass. Where is the position of center of mass? You can take point D as your origin. Take point D as your origin, because whenever you get a question on center of mass, if there are point masses, someone has to tell you which is the origin. Do you understand which is the origin? If the origin changes, the position of the center of mass will change. It will look different. It will be there, but it will look different. So you take D as your origin. Taking D as your origin, my dear friends, get me the answer, and your time starts now. That's my dear friends. Anything that looks like an answer? Nothing? That means I need to do it then? Is that so? I'll give you 1 more minute.
Sir, it is 1/2 comma 7/10, sir.
1/2 comma 7/8. Let me check what answer I have. Just give me a minute. Again, I hope that everyone has tried it. Yes or no? You just need to do simple things together, and you would be done. Yes or no? Just give me a second. Everyone getting the same answer? Okay, let me come back. Okay. What is the answer that you're getting, beta?
1/2 comma 7/10, sir.
1/2 comma 7/10. They are getting 3/10. I think your answer would be correct, because it all depends on where you have taken your origin and where you have placed all these 4 particles. So I'll just show you my way of doing it. Okay. So particle D is placed here. So I will assume that particle C is here. And then I will assume that particle B is here and particle A is here. Since the diagram is not given, you are not sure where they are kept. But this is how you should take the particles. If this is the way you have taken the particles?
No, sir, I have taken B and D opposite, sir.
B and D opposite. I told you D must be taken as the origin. This is 4 kg. This is 3 kg. This is 2 kg and this is 1 kg. First of all, you can find out the x coordinate of center of mass. Yes or no? So you multiply 3 by 1. Yes or no?
Yes, sir.
Plus you multiply this 2 by 1. Plus you multiply this 1 by 0. Plus you multiply this 4 by 0. Got it?
Yes, sir.
And divide it by 1 plus 2 plus 3 plus 4. Whatever you get is your answer. To get the y coordinate of center of mass, this 3 is multiplied by 0. Yes or no?
Yes, sir.
Plus 2 is multiplied by 1. Yes or no?
Yes, sir.
Plus 1 is multiplied by 1. Plus 4 is multiplied by 0. You divide it by 1 plus 2 plus 3 plus 4. Whatever you get is the answer. Everyone did it this way or we did it in some other way? If you did it in some other way, got this everyone?
Yes, sir.
Now I'll give you a diagram so that no one does anything differently. Question number 3, you can take the origin at this point, find out the center of mass of this system. Take your time. Everyone got it, bacha? Are you trying?
Yes, sir.
Okay, do it. I'll give you 2 minutes.
Sir, it is 4 comma 3 4 by 3 by 4.5 by 3, sir.
Okay. Everyone got the same answer? I must be sure that everyone are getting the same answer. Shall I do it? Yes, bacha? So let us find the x coordinate. How will you get the x coordinate of center of mass? It will be 0.5 multiplied by 0, yes or no?
Yes, sir.
It is placed at the origin, plus this one multiplied by 4, yes or no?
Yes, sir.
Plus 1 multiplied by 4, yellow one, plus this 1.5 kg. The x coordinate is 0 only, yes or no?
Yes, sir.
So plus 0 divided by total mass is 2 kg, yes or no?
Yes, sir.
So you will get the x coordinate of the center of mass. How do I get the y coordinate of center of mass? This one is 0, yes or no?
Sir, total mass is 3 kg, sir.
Oh, sorry. I make mistakes like this. You don't do the same mistake. Okay. So y coordinate center of mass 0.5 kg is on the y 0, yes or no?
Yes, sir.
This is also y 0,
Yes, sir.
yes or no? The only thing that is there is 1.5 into 3, yes or no?
Yes, sir.
Divided by 3. That will give you the y position of the center of mass. You already know the x position of the center of mass, and you are done. Yes or no? No, yes?
Yes, sir.
Anyone got this answer? Yes or no? Please raise your hand so that I know. Yes or no? Okay, that takes us to continuous mass. How do you find the center of mass of a continuous system? What do I mean by a continuous mass distribution? For example, a rod. It is not a point object. Up till now, we were dealing with point objects. There were points in space. We were finding out the center of mass of those system of particles which were point in space. Now, this consists of a very large number of point masses. So this is a continuous mass. So you can have a line mass, one-dimensional mass. You can have a surface mass, two-dimensional mass, or you can have a volume mass, three-dimensional mass. Do we understand this? Yes or no?
Yes, sir.
Now, to find out that, you will have to use the technique of integration. Do we understand this?
Yes, sir.
To get the x coordinate of center of mass, what you got to do is you will have to you will have to break it up into small particles. One of that small particles will have mass dm. You will multiply it by the center of mass ka x coordinate. You will integrate this, and then you will divide it by the total mass. Now, to find out the total mass, again, you might have to integrate. So this will be integral of dm. Do we understand this? But obviously, we are not going to get into that. We are not going to derive everything because there is no point of deriving all these things. What we are going to do is we are going to understand the center of mass of different bodies. Remember, if the body is symmetrical, important point, if the body is symmetrical, center of mass will lie on the line of symmetry. line or axis of symmetry. Do you understand the meaning of this? Yes or no?
Yes, sir.
For example, if you have a rod is taken as a one-dimensional body. The center of mass will lie on the axis of the rod. Yes or no?
Yes, sir.
If you have a rectangular body, the center of mass will lie at the center. Yes or no?
Yes, sir.
If you have a triangular body which is symmetrical about the central axis, isosceles triangle, let us say,
Yes, sir.
one of the coordinate, the y coordinate or x coordinate, depending on how that triangle is kept. If the triangle is like this, the y coordinate can be taken as 0. It will lie on this axis of symmetry. Do we understand this?
Yes, sir.
For a disk, this coin is a disk. It has symmetry. The center of mass will lie at the center. Yes or no?
Yes, sir.
If you have half of this, if you have only one half, let us say upper half is gone, the lower half is there. Even that lower half of that disk is symmetrical about the y-axis. Yes or no?
Yes, sir.
You don't have to find out the x coordinate because the y is the axis of symmetry. Everyone understands this?
Yes, sir.
Going on the same logic, you can note down the various positions of center of mass and then we will write their values as well. So you can note down this small thing. Most of things that you will know, but if you don't know anything, you can write it. For example, for a hollow sphere or a solid sphere, center of the sphere. For a circular ring, center, disc, center, uniform rod, center. Lamina, when they say lamina, this is a rectangular shaped body. Square, rectangular parallelogram, which is the point of intersection of diagonals. Triangular lamina, point of intersection of median. Rectangular or cubical block, point of intersection of diagonals. Hollow cylinder, midpoint. Solid cylinder, midpoint. Cone or pyramid, on the axis of the cone at a distance of 3h by 4 from the vertex of the cone. This is given in a snapshot for every one of you to remember them. Give you 1 minute to note this down. You don't have to note this down, just remember them. No one is going to ask you. But yeah, if a question comes, if you remember this, it will be easier for you to answer it. You'll have to remember a lot of things here. Don't have to write this. I'll give you the values. Can we move ahead? I'll give you the values, don't worry. It was just if a diagram comes and you ask it and they ask you from the diagram what is the value of the center of mass, you can just write it down from there, understanding the value. Now this one, note it down one by one. Number one, what is this? This is semicircular ring. Do we understand this is semicircular ring?
Yes,
It is symmetrical about this y-axis. Yes or no?
yes,
You
sir.
don't have to find out the x coordinate. You only need the y coordinate. Yes or no?
Yes, sir.
And what is the y coordinate? Do you know? It is 2r by pi. If you don't know it, now you know it. Draw this diagram. Write the answer and stay happy. This is semicircular ring. Have you drawn it? Once you draw it, please let me know. Shall we move on in life? Life has to move on.
Yes, sir.
The next one, what is this? It is semicircular disc. What is the difference between a ring and a disc? A disc is solid. Do we understand this?
Yes, sir.
It is solid. Again, it has an axis of symmetry along the y-axis. Yes or no? So you only need to find out the y coordinate. And remember, the y coordinate is the center of mass of this one. 4r by 3 pi. 4r by 3 pi. I hope everyone is noting this down. Yes or no? No, yes.
Wait a minute. Done, sir.
Everyone, sir?
Yes, sir.
Next one is known as this annular ring. Annular half ring or half disc. Now, how do you find the center of mass of this? So basically, you do it by what I call negative mass system. What do you mean by negative mass system? What do you mean by negative mass system? What do you do is, you consider that this disk is not having any hole. You can understand that this disk is having a hole, yes or no?
Yes, sir.
So consider that it is not having a hole. Find out the center of mass of that. Take the mass as m. Then find the center of mass of the whole part. Subtract that 2 and you will get the answer. You can't do so much in an examination hall. So you just remember the answer here and the answer here. Which coordinate we need to find out here? X coordinate or the y coordinate?
Y coordinate, sir.
The y coordinate of the center of mass looks like this: 4 by 3 pi r2 cube minus r1 cube divided by r2 square minus r1 square.
Yes, sir. It's done.
Everyone got this? The next one is solid hemispheres. Hemisphere is solid always. So I'll just call it hemisphere. When I say hemisphere, it is always solid. If you don't understand, you can write solid. Which coordinate we need to find out here? Tell me, fat.
Y, sir.
Only the y coordinate. The y coordinate is 3r by 8. So you can also keep on drawing so that you understand which coordinate and how we have placed that.
Yes, sir. Done.
Next one. This is hollow. Hollow hemisphere. Again, the axis of symmetry is x-axis. You only need to find out y, and it is simple to remember. It is r by 2.
Yes, sir. It's done, sir.
Triangular plate. Which coordinate we need to find out? Huh?
Why, sir?
Here. And the y coordinate is h by 3. Shall we move ahead in life? Huh?
Yes, sir.
Next one. Solid cone. Cone is always solid. Which we need to find out? Only the y one. H by 4.
Yes, sir. It's done.
Next one. Hollow cone. Solid hollow both. Y coordinate. H by 3. So hollow cone and triangular plate both are same. Everyone understands this? Yes or no? No or yes? It has gone above what I'm saying bye bye. I'm going. Don't worry about me.
Understood, sir.
Pakka now, sir?
Yes, sir. Done, sir.
If you are symmetric, so it is
Sir.
at the center. We understand this?
Yes, sir.
Yes or no? No, yes. Remember, the more the number of things that you can recollect and remember, you will not have to solve them in the examination hall. This one, this is the arc of a circle. Arc of a circle. Its substance and angle. 2 theta at the center. Which coordinate should I find out?
X coordinates.
Yes or no? The y coordinate here lies here. Yes or no? So I need to only find out the x coordinate. Do we understand this? It is r sine theta by theta. Everything has to be in radians, not in degrees. Do we understand this?
Yes, sir.
So
Yes,
that becomes the general formula. With this general formula, you can also find it for semicircular. For semicircular, angle theta is how much? 90, because 2 theta is 2 theta is 180. You put the formula, you will get the answer 2r by pi. Getting my point?
Yes, sir.
This is a general. Now applying the formula, can you get me this one and remember it? Where will it lie? It will lie on this perpendicular bisector, yes or no?
Yes.
On this angle bisector at the angle of pi by 4, yes or no?
Yes, sir.
So total angle is 90, so half angle becomes pi by 4. In this formula, you put theta as pi by 4 and you will get the answer. You will get the distance from this point, and from there you can find out the y coordinate will be 2r by pi. It is same as that semicircular part. The x coordinate is also 2r by pi. This total distance is 2 root 2 r by pi. So remember this. Okay. One last. I think I can put it here. One last, and this is a sector of a circle. Which coordinate should I find out? Only the x1, yes or no?
Yes, sir.
Remember the general formula for the sector of the circle, 2r sine theta divided by 3 theta. For arc, it is r sine theta by theta. Here you multiply it by 2 by 3 and you get your answers, my dear friend. I'll give you time till tomorrow to go through these formulas. If you are lucky enough, you might get any one of these in the exam straight away. Else, we will do some questions and we'll wind up this topic of center of mass by tomorrow's class. Let's hope so. So I hope you have understood what we have done in the class. We have understood what we mean by center of mass, and we have seen the center of mass of some unique configurations. We will move ahead and solve some problems based on this in the next class. If you have any doubts, come up till me. Else, it's a wrap from my end. I hope you have understood everything. You have to remember all these formulae. I don't think they are tough to remember if you understand the pattern of remembering them. Take care. Have a nice day. Bye bye, bacha.